Welcome to EDU World Space.
Let's express this given number as a ratio of integers. This means we're looking for a fraction of the form p over q, where p and q are integers, and these are numbers of the form like 0, 1, 2, and so on, and also in the negatives of these numbers. So no fractions, no decimals or pies or anything like that. So now what we can do here is just start off by pulling out that 1, and then I'd also pull out this 2, 3, 4 because it only appears once, and then we see that this 5, 6, 7 will start repeating. So let's start that in a different color maybe. So for the 5, 6, 7, so I'll put the 3 zeros before this because these first 3 spots are already being occupied by the 2, 3, and the 4. So there's no reason to put a non-zero here. And then we have our 5, 6, 7. But then after that, we have another 5, 6, 7. So I'll put another 3 zeros for the same reason. These 3 zeros here are being occupied by these 3 numbers. So I just want to put zeros there. And then we could even go one more time. This time I would put 9 zeros because the first 9 positions have been occupied, where this 7, 8, 9 has been occupied in the previous step by these 3 terms here. And we can see that starting inside of these green parentheses, this is when the pattern starts. This is the more interesting part of the problem. Here you can see that the decimal is always moving 3 places to the left. So this is equivalent to saying that this is geometric and that we're multiplying by 1 over 10 cubed each time. Since we're multiplying by the same thing each time, this is geometric. And since we know that it moves 3 decimal places to the left, that's the same thing as dividing by 10 3 times. So this tells us that what the R is. So now let's go ahead and start rewriting these as fractions. I can write this fraction here as 2, 3, 4 over 1,000. So let me just write that over 10 cubed. And then inside the parentheses, we have 5, 6, 7 over 10 to the 6th. 5, 6, 7. And then since we multiply by this each time, 3 to the left, we'll have a 9 there. And so on. And here I should have put the dots to indicate that the sum continues. So again, the first term I had to put a 6 on the bottom there because we're going all the way up. This is 6 places after the decimal. So since this is a geometric series, we can go ahead and actually find the sum here for this large sum inside the parentheses. We know that for geometric series, the sum just equals, you take the first term in the series, and then you just divide by 1 minus r. So this lets me write this as 1 plus 2, 3, 4 over 10 cubed. That's just the first 2 terms from over here. And then using this formula, the first term in the series, we can see that just by looking at it here, 5, 6, 7, 10 to the 6th. And then I divide by 1 minus r, and r is 1 over 10 cubed. Now, since I am running out of room here, let me go ahead and write this on the next page. We have 1 plus 234 over 10 cubed, and then 5, 6, 7 over 10 to the 6th, 1 minus 1 over 10 cubed. we could go ahead and just rewrite the first two. And then we can rewrite this, get a common denominator there. And then we have, after canceling up here, and then maybe we can add these two fractions first. 8, 6, 7, 9, 37,000. And then get another common denominator here. So 45,679 over 37,000, and that's our final answer.